Hello friends, this is lecture number 9 of Fourier series, complex form of Fourier series. Today we're going to discuss about complex form of Fourier series, right? Mathematical physics for BSc and MSc students, and I'm going to show you how to obtain the complex form of these two functions. Okay, so before we start, please subscribe the channel if you are new to my channel. Also share with your friends. If you like my video, hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. And one more thing, that if new video will be uploaded, then that must be appearing at the end of the screen. That means at the end of the video, okay, with the playlist. And if you want to watch all the previous lectures, then links are in the description box from lecture 1 to lecture 8. So now let's start. So now you see complex form of a Fourier series of a function f of x in this interval from minus L to plus L is given by this. This is the complex form of a function, and where this Cn is given by this relation, right? So remember that. And here small n belongs to capital N, that means natural number. N is natural number, right? So now let me take the first function, this first question. Here we're going to obtain the complex form of this e to the power minus x. So let me take it. So here the given function is f of x. Here the given function is e to the power x, right? E to the power minus x, not only x. And in the interval minus 1, this x is greater than equal to minus 1 and less than equal to 1. That means interval is minus 1 to plus 1. So we know that the complex form of a Fourier series is given by this. F of x is equal to summation Cn e to the power minus I n pi x by L. And here this f of x is nothing but e to the power minus x in this case, right? And here the value of L, this is for interval minus L to plus L, right? This is for the interval minus L to plus L. So here the interval is minus 1 to plus 1. Obviously L is equal to 1, so that's why we can replace this L by 1. So if you do so, then we can write this only. Fine. So hope you have understood. This is suppose equation number 1, right? And how to obtain the Cn? We know the value of Cn is given by this formula. Cn is equal to this, right? So here L will be equal to 1, so let me make it 1. So here we're gonna have plus 1, this is gonna be plus 1, and this is gonna be minus 1. And here if it is 1, 2 ones are 2, so we're gonna get here 2 only, right? So hope you have understood this. So now let us obtain the value of Cn here. So now let me go to the next slide and let me copy this one first. To obtain the value of Cn, let me go to the next slide. So here is Cn. Okay, so how to obtain this? So now you see we have already that f of x is equal to, that is given, the function is minus e to the power minus x. So let us put f of x is equal to minus e to the power minus e to the power minus x, yes. So 1 by 2 integration from minus 1 to plus 1 e to the power minus x e to the power minus I n pi x dx, right? And if you simplify this, then what you're going to get, then 1 by 2 from minus 1 to plus 1. And if you apply the laws of indexes, then you're going to have e to the power minus, taking minus common, you're going to get this. Okay, and you can take x also common, right? So on taking x common, then you minus x taken as common, 1 plus I n pi, right, dx. That's going to be simplified form, right? So now what we're going to do, we're going to integrate this. If you integrate this, what you're going to have, so we know that integration of e to the power mx dx is given by e to the power m by m, right? So we're going to apply this formula. Then what we're going to have, 1 by 2, so integration of e to the power minus x 1 plus I n pi x, sorry, x is taken common, n pi, then it's going to be minus 1 plus I n pi, right? So here minus 1 to plus 1, right? So if we put upper and lower limits, then what we're gonna get? So then minus 1 by 2, let me write these things outside, 1 plus I n pi, right? And within bracket we have e to the power minus, on putting plus 1, we're gonna get minus 1 into 1 plus I n pi, and if you put lower limit, that is minus 1, then it's gonna be plus 1 plus I n pi, right? That's what we're gonna have, right? So what we can do, we can take minus sign common, or you can multiply this minus 1 here and here. So then what you will get, then if you do so, this negative will be positive and this positive will be negative, right? So then what we're gonna have, let me write 1 by 2 and positive 1 plus I n pi, then reverse the sign of term inside the brackets, okay? Then this second term, which is negative, that's gonna be positive, so e to the power minus, plus 1 plus I n pi, right? And this first term, which is positive, that's gonna be negative, right? So minus e to the power minus 1 plus I n pi, right? So that's what we're gonna have. So hope you have understood this. So now you see, if you simplify this, so this is Cn. Now let me copy this step, then let me go to the next slide. So here you can see, so this is the last step we have got, and here you can see that you can write this term as e to the power 1 into e to the power I n pi. Here you see this term, it can be written in this way, e to the power minus 1, then e to the power minus I n pi, right? So here you see, you must remember two identities, that those are e to the power ix is equal to cos x minus I sin x, and e to the power ix, if you have e to the power x, that's going to be cos x plus I sin x, and if you have minus I sin x, ix, e to the power minus ix, then you must put cos n pi minus I sin x. That's what we're gonna use this here, okay? So you can see in these two terms we can replace these two terms by these results, okay? So if you replace the x by I n pi, then what you're gonna get, 1 by so 1 minus 1 plus I n pi. Let me multiply the conjugate of this as well, 1 minus I n pi here, and here also 1 minus I n pi, multiplying the numerator and denominator by the conjugate of this, right? And within bracket here, e to the power 1 means simply e, you can write, and you can replace this by cos n pi plus I sin n pi minus e to the power n cos n pi. So now apply this identity, minus I sin n pi, right? That is what we have got. So let me bring these two terms a little bit this side, okay? So this is the result we have got. So hope you have understood this. Now here you see, sin n pi is 0, sin n pi is 0, so we're gonna have cos n pi and cos n pi only, and cos n pi is minus 1 to the power n, cos n pi is minus 1 to the power n. So what we can write here, so simplifying this part, what we have got, 1 minus I n pi, and here 2, if you apply the a square minus b square formula, then 1 square going to be 1, then square of this is going to be I gonna be I gonna be -1, so minus minus plus, then n square pi square, and here we have e to the power 1 minus e to the power minus n, minus, not minus n, that's supposed to be -1 actually. I have made mistake. Okay, that should be -1. Okay, so now e to the power -1, and we have cos n pi here, right? So these two can be written here, right? So we have another identity that e to the power x minus e to the power minus x by 2, then it should be sine hyperbolic x, and here x is 1, so we're gonna have sine hyperbolic 1, right? Sine hyperbolic 1. So 1 minus I n pi by 1 plus n square pi square sine hyperbolic 1, and value of this cos n pi is -1 to the power n, where n belongs to natural number. So let me write the n here, -1 to the power n. Okay, so this is the value of Cn. Let me copy this value of Cn. Let me go to the next. Here is the result, and if we put this value of Cn in equation number 1, this is the equation number 1, and if you replace the Cn by this value, then what you will get, then you're gonna have this was equation number 1, right? So we have put this value of Cn here. This is the value of Cn put here, so then you will get this result, and this is the complex form. This is sine hyperbolic 1. This is the complex form of this function. So hope you have understood. Now let's move on to the next question. Here you see this is the next function, which is expressed in the form of Fourier series in complex form, and here the interval is -L to +L. So this is the given function I have written in the solution first, and this is the interval, and we can consider the Fourier series of this function is of this form, and the value of Cn can be obtained by this. Now let me show you. So Cn will be equal to this. So this is the value of this Cn, right? And here you see this f of x is replaced by this function, given function a to the power x, right? So hope you have understood. Now let's go to the next slide. So this is the value of Cn we have got. Now if we multiply this, what will happen? If we simplify this, then what you will get, and simplifying these two, applying the laws of indexes, what we're going to have, 1 by 2l integration from -L to +L e to the power ax minus I n pi x by L. That is what we're going to have, right, by L dx. Now so from here this x can be taken common. On taking x common, what we will get, we're gonna get this result, right? So just wait. So on taking x common, we're gonna get this result, right? Now apply this formula, e to the power mx by mx dx. That's going to be e to the power mx by m, right? If we apply that formula, then integration of this term will be, so now let me write 1 by twice L e to the power x a minus 1 by n pi by L by a minus 1 I n pi by L. That's what we're gonna get, and we're gonna integrate it from minus L to +L. These are the limits we are going to put here, and this term can be taken outside, and if you multiply this term with twice L, then what you will get, you're gonna have 2al minus I n pi. That's what you will get, right? And if you put the upper and lower limits here, then what you will get, e to the power L a minus I n pi by L, and again if you multiply it here with these two terms, then what you will get, then your result will be something like this, a L 1 minus n pi, right? L will be cancelled. then minus, if you put the lower limit minus L, then your result something should be like this, minus AL, then okay, minus AL plus IN pi, right? That's what you will get. And from here you can see, you can write this term as a to the power AL into e to the power minus e to the power AL minus into e to the power minus IN pi, right? And this one also can be written as e to the power minus AL e to the power IN pi. That's what we can write. Okay, so now let me copy these things. Let me go to the next slide. This is the value of Cn, right? So here is the last step we have got. This is nothing but Cn. So what we can do here, again here we're going to apply this formula, e to the power ix, that is cos x plus I sin x, and if we have e to the power minus x minus ix, then we're going to have cos x minus I sin x minus I sin x. So if we apply these identities, then what we will get? So this is the result we're going to obtain. So let me close the bracket. So here small n belongs to capital N, that means natural number. So we know that sin n pi is 0, and cos n pi is minus 1 to the power n, right? Value of cos n pi is equal to minus 1 to the power n. Sin n pi is equal to 0, right? So if we use that values, then our result will be something like this. Then what we're going to have here, you can see that 1 by 2 AL minus I n pi, then within bracket we're going to have e to the power AL minus e to the power minus AL, and here we're going to get cos n pi, instead of writing cos n pi, let me write here minus 1 to the power n, right? That's what we're going to have. So I have taken this cos n pi common and I have put the value of cos n pi, right? That's what we have done. So this 2 can be written here. You can see this 2 can be this 2 can be written here. Okay, so again apply this formula, sine hyperbolic x is e to the power x minus e to the power minus x by 2. So if you apply this formula here, then what you will get? Now let me copy this and let me go to the next slide. Okay, so if we apply this formula here, then we're gonna have Cn is equal to 1 by AL minus IN pi sine hyperbolic. So instead of x we have AL, right? Sine hyperbolic AL, then we have minus 1 to the power n. So let me write here minus 1 to the power n. So that is what we have got, the value of 1. So now using this value of Cn, not 1, value of Cn, putting the value of Cn in equation number 1. So what was equation number 1? Let me go back to the first this. Okay, this is equation number 1, right? So now let me copy this equation number 1. Then okay, this is the slide. So this is the equation number 1. So now let me put the value of Cn here. Okay, let me clean these things. So this is minus infinity. So let us put the value of Cn. What is the value of Cn? Value of Cn is this. This is the value of Cn. Let's put here. Okay, so then what you will get? Then you can have e to the power ax is equal to summation minus infinity to plus infinity minus 1 to the power n by a minus IN pi sine hyperbolic AL e to the power I n pi x by l. So this is the complex form of this given function e to the power ax. So this is our answer. So hope you have understood. So thank you for watching. See you in the next video. Okay, so subscribe the channel, share with your friends, and help me to grow my channel. Thank you.